In this lesson, we are going to do what Ilithia did with her cool portfolio. Let me show you what it is. We are going to achieve this kind of effect. As you can see, we have a huge text in the middle of the scene with some objects floating around, and we are going to do that with Three.js. So yeah, let's go. As always, the link is at the bottom on the links panel. So we are going to use the text buffer geometry. This is a Three.js class, and it's a very specific class that we didn't use until now because it's a little harder than just creating a cube or something like that. We will also have to use a very specific format of font called typeface. We are going to discover what is a typeface exactly. So yeah, how to get a typeface font. First, you can convert a font you already have, like on your computer, or maybe you download it here from somewhere, and you can convert it by using this tool. All right, you just upload the font here with this button. You have few options, and then you can convert it. It will give you the right file. Obviously, as always, you must have the right to use that font. You cannot use any font just because it's on the web, so make sure you have the right to use that font. Another solution is to use the fonts provided by Three.js, and you can find those fonts in the forbidden folder, which is in the node modules folder right here. If you go to the node modules and then Three.js folder, I have already my setup running. All right, you should have something like a cube in the center of the scene, and you can just rotate around. This is the setup. Start it and get back to the video. So I was saying that in this folder, in the 3 dependency, we can go to examples, font, and here you have some typefaces font. Cool, so we can use them. What we are going to do is use some of them and put them in the static folder. Well, actually, there are multiple ways of doing it. If you want, this is not what we are going to do in this exercise, but if you want, you can just load those fonts from the script.js file by doing import, and you can name it as you want. It's going to be typeface font from, and you just have to write, and we have something very similar, the path starting from the three dependencies. So it's going to be 3 examples with an S, examples, and it's going to be Helvetica. This one is really long. Helvetica regular typeface font, typeface.json. This is the one we are going to use. Don't do it because we are going to do another solution. I just want to show you that it is possible to do this way. And if I log it, I get something. And this is the typeface font, and I can use it to create this big text geometry. What we are going to do is a mix between them, and we are going to take the fonts. I don't know which one. We are going to use the same one. So it's going to be Helvetica regular typeface. So Helvetica regular typeface. This is the one. Yeah, right here. And take the license with it, because we are supposed to keep the license in the same folder. And you can put them in the, where it is, the static folder. And you're going to create a folder. Why am I doing this? It's because I want you to practice loading fonts and handling, creating assets in the scene, creating mesh in the scenes while you have things to load. All right. We could have used the typeface font right here and we would gain something like 10 minutes, but we need to practice in order to get better. So in the static folder, create a fonts folder with an S and copy and paste the font we just set. So it's Helvetica underscore regular dot typeface dot JSON. And we have to provide the license with it. All right. If it's for personal project, I don't think it's that important, but let's do that. All right. If it was too fast, pause the video and get back to the video once it's done. I'm going to remove this because we are going to load this font. Right now we are getting the font from the node modules folder, which is a way of doing, but I don't want to do that way. I want to load this font. So I save. I have nothing in my console anymore. And we can start loading the font. To load the font, we are going to use the font loader, which is great because there is a class that can handle this part. And as always, you also have an example in the documentation. The documentation is really good. You should spend some time in it. It's really great. So yeah, let's go. I'm going to put it over there. Yeah, I don't know exactly where I should put it. Let's say right after the textures. Maybe it's a bad idea. We'll get back to it later if we need. So I'm going to do fonts. No, right here it's fine. You'll see why. Font loader, so you have to instantiate the loader. And only one font loader can load multiple fonts. So if you have multiple fonts, just instantiate one font loader, just like we did for the texture loader. And we are going to use the texture loader already in the code, by the way. 3.font loader. And then we can load the font by doing font loader load. Be careful, it's working differently from the texture loader, because with the texture loader, don't do it, but I can show you. You can do something like texture loader load, and here you would get the texture and you can use the texture right away. This is not the case for the font loader. We cannot have a font like this. Cannot do that. We have to use the callback in the parameters. So first we need to provide, I will show you exactly what it is. First you have to provide the path to load the font. So it's going to be Helvetica. It's hard to write. You know what? I'm going to copy and paste it. Just copy and paste the path of the file. And then you have to provide a function which will be triggered once the font is loaded. All right, you have to do that. So you can use function, but I prefer to use fat arrows like this. And we can just test. We can do like font loaded like this. You save and you get font loaded. If you get something else, let's say I did a mistake in the name, we get an error and the font loaded doesn't show up in the console. This is probably a problem with the path you provided here, or the files you didn't, maybe you didn't put the right font in the right folder. So make sure you have something like this, static fonts, and the font right here, and make sure it's the right font. There are two Helvetica. There is a Helvetica regular and something else. I forgot which one exactly. Once it's done, we can move forward. Yeah, we saw that. Okay, it's time to create the geometry. We are going fast here, which is great. We are going to use the text buffer geometry. I already shown you this. This is this class. But do not use the example right here. All right, it's a good example, but not in our case because the values are way too high. All right, our camera is standing like 3 units from the center. And this is the kinds of unit you will have, and you will get like a huge font, and maybe you won't see it because you will be inside the font. So do not use those parameters, or you have to move the camera backward. Anyway, I'm going to provide you the right parameters. So hang on, we are going to do the geometry, the material, and the mesh here. I'm going to call it text geometry because we are going to have other geometry soon. Text geometry, and we are going to use new 3 text buffer geometry. All right, it's this class to get this kind of text. In the parameters, the first parameter you have to provide is the string. So you can do any text. You can write, I don't know, Bruno Simon if it's my portfolio. We can write what Elithia did, I closed it. Anyway, you can put anything here. I'm going to use hello 3GS. Put anything. Maybe special characters won't work. Just test them. You will see. And here we can provide a lot of parameters that will generate this font. And we can tweak a lot of things here. So first we need to provide the font. And when we use the font loader here, when this function is being triggered, we can get the font right here. All right, I can show it to you. You don't have to do it, but I can show you that we get the same font as we did when loading directly from the node modules folder. And we get, never mind, I forgot to fix that. So it's going to be typeface. Yeah, and we get a font. All right, and we can use this font. So this is the font, cool. the first thing we have to provide in the second argument, which is an object, is that font. All right. And by the way, in JavaScript, now you can do this. If the property of the object is the same as the variable, which is our case here, you can just write it this way. I won't do it because I want to use simplest version of doing things, but you can do it. Then we have to provide the size, and we will just test those parameters shortly, don't worry. The size is more like the size of the font. The height is going to be the depth of the font, if I'm right, at least. We are going to test. Curve segments, I don't know. Let's just use those parameters. We are going to tweak them anyway. Bevel enable, oh, that sounds interesting. All right, let's put true, just like in the example. I will show it to you, don't worry. Bevel, so we have a lot of things about bevel. Bevel's thickness, we are going to use 0.03. Bevel size, 0.02. Use different values here. We'll understand why shortly. Bevel offset, 0. And bevel segments, 5. All right, that's a lot of parameters. This is where most beginners just get stuck because they can't see a good result, and there is so many parameters that they get lost. You have to test them until you understand which parameter is doing what exactly. And right away, we are going to do the rest, which is creating the text material by doing new 3. It's going to be a mesh basic material because we just want to focus on the geometry right now, and we will test other materials, obviously, later. We won't put any parameters here. Maybe you remember which color will be the material if we don't put any parameters. And then we can create our mesh, just like we used to do it. We have a geometry. This is the geometry. We have our material, and we can create a mesh, and you know how to do that. 3.mesh, you provide the geometry, and you provide the material, like this. And what did I forget? As always, I forget a lot this. We have to add it to the scene. Scene, add, text. And yeah, it's working. We have our hello 3GS. But when we refresh, as you can see, this is the center of our scene, where the cube is, and this is our text, so we have to center the text. Yeah, we can get rid of the cube. It's supposed to be right below. So remove the cube and the object part. We don't need it. So we can focus on the text. So, is there a way to know really the shape of it? Because we use a mesh basic material and we can't see much about the exact shape. What you can do is provide a wireframe. So as we saw in the previous lesson, we can do this like that. Wireframe true. And we can enjoy the wireframe, or you can change it after by doing text material wireframe true. This is the same, you will get the same thing. All right, it's working. Cool. So as you can see, we have a lot of details, and we can see the bevel. All right, look at this. We have a bevel here. This is great. We can do like round fonts, round text, and which is great. We don't have to calculate it on our own. Cool. But we have too many triangles, and we are going to start to think about performances, because we need experiences that work well on every computers, on most computers at least, and we are going to optimize it. The question is, can we remove some triangles? As you can see, those letters are fine, but those with round curves, they are bad. See, there is too many triangles here. We won't see a difference if we remove, I don't know, maybe half of the triangles. What you need to do now is lower the curve segments to test the result, and you also have the bevel segments here. So the curve segments is about this. All right, it's where I have my mouse right now. And the bevel segments is about this right here. So you have to lower those, and we are just going to test, I don't know, maybe 6. Let's see the result. Yeah, it's still okay. If we get too close, we can see the faces, but we will stay quite far. So I don't know, maybe use 5 as low as possible, as long as we cannot see the difference from a default camera angle. And the bevel segments, maybe 3. Let's see. Yeah, 3 is fine. All right. 4. Yeah, we want some details. All right, that's cool. Always optimize. It's important. Yeah, as I told you, the text is not centered. What you can do, this was not supposed to be part of it, but let's do it. We're going to add an axis helper to help us find where is the center. And because there is a small thing I want to show you. So we are going to add the axis helper. If you forget what is an axis helper, don't worry, you will understand shortly. You're going to create an axis helper variable and do new 3 axis helper, no parameters here, and just add it to the scene. And we use this one at the beginning, and this is just that. This is the axis helper. So we can really see where is the exact center of the scene. And we see that the Z, positive Z is going toward the camera, positive X is going to our right, and positive Y is going to the top. Okay. So our objective now, our goal is to center the text. Why do we need to center the text? We could just move the mesh a little and it will probably be fine. But if we want, I don't know, to do rotation on it, it would rotate on the edge, on the bottom corner of the edge, and it would do something like this, which would be not very nice as an animation. We want to be able to move the text something like this. We won't be doing the animation, but it's always good to have things centered properly. We have multiple solutions. We have 2 solutions. We are going to use the first one, which is by using bounding. So what are bounding? First, I want to show you something. I forgot to show you, is that the center is right here. Maybe if I refresh, no, I cannot do that. The center is not the exact corner of the H of hello, all right? The center is right here on my cursor. I would have thought that the center is here. And we have to remember this. We are going to use that a little later. So we are going to use the bounding, but what are the bounding? Well, the bounding is an information associated with the geometry that tells what space is taken by the geometry. You cannot see it, but there is information about the space taken by this geometry, and you can have one for every geometry. It can be a box or a sphere, and I did a small render in Blender to show you that. This is a box surrounding my sword. It's just a box which goes at the exact limits of my geometry, and you can also have a sphere like this. You cannot see them, it's just to represent them, but you can have them in a mathematical way. Why does 3GS have this box and sphere bounding? Well, it's for something that we call frustum culling. It can be used for many things, but it's usually for frustum culling. Frustum culling is about rendering or not rendering the object. If an object is behind the camera, you don't want to render this object. If you have, I don't know, like a full world with many things behind the camera, and you just look, I don't know, in the sky and you have a spaceship, if you render everything behind, you will have performance issues. And 3GS will calculate we calculate which objects are in the screen by using those boxes in order to calculate easily. 3GS won't use every vertices and test maybe if one vertices is in the screen. No, they would just use mathematical calculations with box and spheres bounding and know if it's supposed to render this object. All right, it's for frustum culling. But in our case, we are going to use a box bounding just to move it at the right position. Okay. By default, 3GS is using sphere bounding. We are going to use the box bounding. But first we have to say, calculate this bounding, all right? We need to update this box bounding because 3GS by default doesn't use it, so the value of the box bounding isn't right. Actually, I think it doesn't even exist. To do that, it's on the geometry. So for us, it's text geometry, and it's going to look like compute bounding box. Like this. You just save, nothing happens, cool, but right now we have access to text geometry bounding box. And it looks like this, and we get a result. If we didn't do compute bounding box, we get null. And if we do compute bounding box, we get it. What we get is a box 3. A box 3 is not a visible box, all right? It's not a geometry. You cannot use it to create a mesh or something like that. It's just mathematics, and it's just coordinates. And we get a minimum value and a maximum value. And if you check those values, you can understand what's in here. In the minimum value, we get x minus something. It's close to minus 0.2. 0.2, maybe you know where this is coming from. And this is the problem. This is why we get a minus a mean value like that. All right, it's minus 0.2. It seems that it's because of the bevel. And we get the same result on the y. See, it's minus 0.16. This is a little more strange. So yeah, it's this. Okay, and then on the z, so this is the z, we get exactly the same problem. This is the center of the scene where my cursor is right now, and we get something like minus 0.3. And in the max values, we can test those. We get something like 4, so 1, 2, 3, 4, yeah, that's it. And on the y, it's 0.5, so you get something at the middle of the greenish stroke. And on the z, it's something like that. So yeah, it's 0.23. So it goes there. All right, we are just testing things. So we get used to 3D space and to understand the values and maybe to test the values and see if there is something wrong. And there is something wrong, which is because our center is here. And here we get a negative value. We were supposed to have 0. And we are going to use this. All right, now that we have those coordinates, we can understand like the size of the text, and we can move the text to its center by removing half of it. It's just like that. We take the size of the text, we take half of it, and we move back of half of it. And we are supposed to get a centered text. Let's do that. We are going to move the geometry. We are not going to move the mesh. This way the geometry stay, the mesh is where my finger is, and I move my geometry like this. This way when I move the mesh, I rotate the mesh, it rotates on its center. The whole geometry will rotate on the center, which is why we are moving the geometry instead of the mesh. So yeah, let's do that. We're going to use text geometry, and in the text geometry we have access to translate because text geometry inherit from extrude buffer geometry, which inherit from buffer geometry, and in the buffer geometry we have translate, which will move every vertices. Great. Translate, and the the formula here are going to use the bounding box and move back of half of the bounding on the x, y, and z. So to get the bounding, we already did, it's text geometry bounding box, and it's going to be the max. And max is a vector 3, so we can use the x value. And we are going to move back, so it's going to be minus, like this. And it's not full back, it's just half of it. So I can multiply by 0.5. If you prefer, you can do divided by 2. All right, it's the same. I just prefer to use always the same technique. So I prefer to multiply by 0.5. You do the one you prefer. And we are going to do the same for the other two axes. So it's going to be y and z. And we can test that. All right. Text geometry bounding box max x, y, z. we are removing from it, we are subtracting it, and it's just half of it. We save, and we get this, which is nice. It's almost done. It seems center. It is not, but it looks like it. It is not because of the problems I told you about the bevel thickness and bevel size. So we won't be able to see much of a difference, but trust me, this is not the exact center. And actually you can test it. Look at this. We can recompute the bounding box and log it by doing text geometry. Bounding box, like this, if I'm right. Yeah, we get this. So we recomputed the box geometry, which is supposed to fill the text. And as you can see, maximum value is 2.08, great, and minimum value is minus 2.10. This is not logical. We are supposed to have the exact opposite. And this is because of the bevel. And we have to apply the bevel. There are other ways of doing it. It's not the right way of doing it, but I want you to understand bevel, how bevel did change the geometry and centering. So our bevel size is 0.2, and the bevel size is, if I put right here, it's that from here. Let me show you like really close. It's from here to here. And from here to here. So it's like that. So it's going to influence the X, like here, and the Y. So in the X and the Y, we're going to do minus 0.02. And be careful, this is mathematically wrong. We have to put it inside parentheses and divide this value by 2. All right, it's this whole value. And in the Z, this is about this value. Yeah. Maybe I can show you. Yeah, right here. This is this depth. All right. So we have to do minus 0.3. Oh, sorry. Wrong. It's going to be like that. I get it. Okay. Minus 0.3. And right now it's really centered. As you can see, X and minus X. So max X and min X are the same. We can remove this. So this was the hard way. Actually, there is a more simpler way, but I wanted to show you this because we would learn about box 3D, about frustum culling, about those compute bounding box, about those spheres. So it was important for me to show you those. But there is a more simpler way, which is by using text geometry center. So we can just use the center method, which is somewhere like here. Center the geometry based on the bounding box. And it's exactly what we did. So the 3GS does support this. All you have to do is comment this. I will let it in the code, but you can remove it and do text geometry center. And that's it. Much faster. All right, let's add some materials because we like this wireframe style. I mean, I like this wireframe style, but we need something that looks better, just like Edithia did on her portfolio. We're not going to use the mesh normal material. We could have, which is a great material. It looks great, but we're going to use matcap materials because I like matcaps even better. More control and I just like it. So yeah, if you remember the matcaps, it's a reference picture, and I can show you from the folder in the static textures matcap. And here are the matcaps. All right, it's a reference pictures, and this picture will be applied on the geometry according to the normal relatives to the camera position. So there is a complex calculation behind. We don't really care. What we want is apply those cool matcaps to our geometry, to our mesh. So what you can do is use those matcaps. All right, I provided you 8 matcaps, which is a lot, or you can just download one. So if you want to do it, go to this, you can do a search on the web, or you can use this link I provided you at the bottom. Click on the link and you have a lot of matcaps. So you can choose one you like. Be careful if you use one of those matcaps, if it's for personal project, I think it's fine. But if you're going to put it online or use it for professional projects, make sure you have the right to use them. Be careful. The people that gathered all these matcaps haven't checked the license. All right. I think it's written somewhere at the top of it. So you have to check those license on your own. All right. So yeah, choose one. Don't spend an hour choosing one. If you want, you can use those I provided you in the matcaps folder. And we are going to load one. So yeah, let's go. It's going to be in the texture part. I already added the texture loader in the code. So all you have to do is matcap texture equal texture loader. And we did that already quite a few times. Load. And we have to provide the path. And it's the path starting from inside the static folder, which is textures, matcaps. And we are going to start with the first one. / textures. Matcaps 1.png. All right, it's not JPEGs, it's PNG. Let's make sure everything is working by logging the material. Yeah, it seems to be working. No error in the console, which is fine. I can remove the console. That's cool. We can use it inside so copy the matcap texture and we are going to use it inside the text material. To use it with the text material, you can do it like this, like matcap. So this is the way of changing the matcap for matcap material. Oh, careful. It's not a mesh basic material. It's a mesh matcap material like this. And you can provide the texture here in the matcap property. All right. Don't forget to remove the wireframe. It looks really strange. And you get the matcap working just fine. That's cool. And the other way of doing it, just to show you, don't use this technique. Well, actually, you can do whatever you want. I won't be using it. You can remove it from the instantiation and do it after on the property itself. You get something like that. We can remove our axis helper, so I remove it. So we can enjoy our beautiful text like that. So you can do it this way. I'm going to do the previous version, which is exactly the same. It's just shorter because it's in one line. That's cool. Yeah, so we have our matcap working. We are going to test other matcaps at the end of the project. Right now we are going to add objects and we are going to add donuts. Torus. But I like to say donuts. They should have named it donuts. It's more interesting, I think. So yeah, we are going to create 100 donuts and we are going to do it the wrong way. It will work, but it's going to be the wrong way. So if you want to do 100 times something, you do for let I equal 0, I inferior to 100, I plus plus. All right, this is basic JavaScript. If you don't know about this, just take your time. We start at 0, we go to 100, and then we just iterate, we increment I, so it's going to be 0, 1, 2, 3, 4, 5, until 99, because we don't go to 100. All right, we are going to create the donuts, so it's going to be donut geometry. So each donut is, we are going to create a donut geometry. We are going to use the 3 torus buffer geometry. Maybe you remember this one. We used it quite a lot. And here are the parameters. Yeah, it's just random parameters, not too many vertices, stuff like that. Then we can create our material. So it's going to be donut material equal. I'm going to do the exact same thing that I did here. And then I can create a mesh, so it's going to be donut equal new 3.mesh. I use the geometry. I use the material. And then don't forget to add it to the scene as always. So scene add like that. That was fast. But you know about this. Maybe it was just too fast, but you should know about this. If not, you just need some practice. So we are going to do that again and again and again and again. Don't worry, you will know that you will be able to do it on your own. So yeah, we have now 100 donuts in the center because they have all been created at the center because we didn't move them. Let's add some randomness in the position. I usually do it before adding to the scene, but yeah, I will do it before adding to the scene. It doesn't change anything. You can do it after adding the donut to the scene. So we are going to do donut position. This is how we move objects. Let's concentrate on the, let's focus on the position X, and we are going to do math random. All right, let's go slow. As you can see, that's really strange. We get like 100 donuts going from 0 to 1 with randomness. I want it to go faster, further, so I can do multiply by 10, right? We get our donuts here. But I want those donuts to be on the left and on the right. No, sorry, on the right and on the left. So for you, it's the opposite with the camera. Two ways of doing it. I can do -5. This is what usually people are doing, and this is working just fine. But what I like to do is to do math random -0.5 and put it inside parentheses so that we multiply this value by 10. I like doing this because I start with a value from 0 to 1, which is a normalized value. We say normalized value when it goes from 0 to 1. I keep my amplitude of 0 to 1, and then I multiply this by doing -0.5, so it's as positive as negative. And then, so this is the center. I have this value. I have as much positive as negative because I did -0.5, and then I multiply it by what I want. I just prefer it this way. You can do whatever you want. So it's working fine. Let's do the other axes, X, Y, Z. And we get something like this. Okay, that's cool. That's very strange. It seems like the donuts are looking at us. I don't feel comfortable about this. So we are going to change the rotation. And to change the rotation, you just need to rotate 2 axes with enough amplitude. All right. It's not really useful to change all the axes because by just changing 2 axes, you can look in every direction. So we are just going to change 2 axes, and we are going to do rotation X equal math random again. And if you remember from the previous lessons, to do half a rotation, it's radians, we have to do math pi. All right, it's pi. We don't need to do a full rotation because the donuts looks the same on the top than on the bottom. So just half a rotation, we get you what you need. So it's going to be math pi on the X. And yeah, we get something random. We do the same on the Y or the Z. It's the same. You just need to do 2 axes. And now it's fully random, which is great. The problem is that they all have the same size. We are going to change this with the scale. This is a great exercise, but be careful. One common error would be to do, I'm going to do a mistake. Don't do it. Just follow me. Would be to do scale on the X equal math random. I don't know, something like that. Y and Z. And as you can see, I don't want to eat those donuts. They have really strange shapes. So it's wrong. The problem is that by doing this code, we are having different random different values for the X, Y, and Z. If you want to have the same donuts but at different size, you have to calculate one random value and use this value on every axis of the scale. So let's do that. It's going to be scale equal math random. So I do the random once and I put it in the scale value, and then I can use it on every axis of the scale, and I get nice donuts. It's working great. And I can also use the set. Instead of setting every axis separately, I can do set, scale, scale, scale. Like this. I got the same result. All right? It's working fine. But there is a huge problem here. It's not optimized. And we can test that actually. I'm going to monitor the time it took for the computer to do that. And you can do it with me. You can do console time, which is just JavaScript with Chromium things to measure time. You can do donuts. You choose a name. It's going to be donuts. And at the end, after I'm going to zoom out. after the loop, we are going to do time end. If you save, you will get the time it took to create those donuts. If I create 1000 donuts, see, it took me like a quarter of a second, which is a lot, actually. It took too long. And we can fix that. If you remember, we can use the same material and same geometry for multiple meshes. Right now, we are creating 1000 donut geometries and 1000 donut material to create 1003 meshes. And we can fix that really easily. Look at this. So we have a quarter of a second right here. We can take the donut geometry and donut material and put them outside of the loop, right here. We are creating only one donut geometry and one donut material, and we use them on 1000 meshes. I save, look the difference, 15 milliseconds. This is nothing. It did it like that. So it was really, really fast. So you have to do those optimization. If you don't do that, you will have like a freeze for many seconds because you can have more than just donuts. So it's really important to do those optimizations. We can go a little further because we have the same material here. Look at the code. It's the same material between the text and the donut. This won't make a huge difference and we can get rid of the console time actually. But we have the same material for the text and the donut. So what we can do is, hang on, stick with me. We're going to remove this one like this. We're going to take this one, actually just rename it material. Use this material instead of text material and use this material again instead of donut material. All right, I do it again. I get back to the beginning. So it looks something like this. We have our text material used on the text, our donut material used on the donut. You remove the donut material because we are going to have only one of those two materials. You rename it because it's not just for the text. You don't have to rename it, but it's better for your code. So I rename material. It's going to be material. And I also rename the one I use in the text because this one doesn't exist anymore. And I then use this material on the instead of the donut material. It's the same result, but it's even better. I have only one material for the whole scene, which is great. And I think we are done. What we can do now is just test matcaps, and this is the moment you can pause the video and test cool matcaps. I'm going to show you the ones I put in the folder. So yeah, this is looking great. We can have a very, very different style. Let's say test the next one. Oh, this is way too much, but why not? We have a raining metal donuts. We can use 4. Okay, why not? I don't know why I put this one in the folder. Yeah, this one is looking great. Kind of a gore, like horror movie or something like that. 6, oh, this looks even worse. It's like flesh donut. Don't want to eat that. 7, kind of cartoonish, maybe like plutonium or radioactive thing. And then the 8, and I love this one. This matcaps is the best matcap ever with great lights, and it looks really cool. There is way too much donuts. I forgot to lower the amount of donuts. Not enough. Okay, great. This is the end of the lesson. I will see you in the next lesson.